There are two types of vector multiplication. There's the dot product and the cross product. Let's look at the dot product. So the dot product is represented A dot B, and it is what's called a scalar operation, meaning that the result of this is a scalar or non-vector value. And so if I have a vector A is equal to ax I hat plus ay j hat plus az k hat, and I have a vector B that's equal to bx I hat plus by j hat plus bz k hat, then the dot product is just going to be ax bx plus ay by plus az times bz. It can also be represented as the length of A, vector A, times the length of vector B times the cosine of theta, we'll call it AB, and theta AB is equal to the smallest angle between A vector and B vector. Now we can also use this to calculate the angle theta, because we can use the formula theta AB is equal to the arc cosine of ax bx plus ay by plus az bz over the length of A times the length of B. And we know that the length of A is just going to equal the square root of ax squared plus bx squared. Oh, sorry. Did that wrong there. Ax squared plus ay squared plus az squared, and the length of v vector is equal to square root of bx squared plus by squared plus bz squared. Now let's look at what the dot product actually represents. So let's take two very simple vectors. Let's start with our blue vector, and we know that we'll start with 5, 0, 0. 5i hat plus 0j hat plus 0k hat. So there's 5 right there. Now, if I were to draw another vector directly on top of that, then what would my dot product end up being? Well, I know the length, it's very easy to figure out the length, right? So my length in that case we'll call it R for red vector. And the length of that we know very simply is 5. And the length of our B vector, we'll call it blue vector, is equal to also 5. So if we do our dot product, then that's just 5 times 5 plus 0 times 0 plus 0 times 0, and that equals 25. And it makes sense using this formula here because the cosine is going to be 0, and that's equal to, well, I know the length is 5 times the length of another 5 times the cosine of 0 degrees, and cosine of 0 degrees is 1, so this comes out to be correct. Now let's make a little bit of a change here. And let's draw a vector that's very easy for us to calculate the length. And we're going to draw the vector 4i plus 3j. So 1, 2, 3, 4. 1, 2, 3. So that is our vector, and this has to be length 5. Remember, 4 squared plus 3 squared is 25. Take square root, it's 5. Okay, but they're not right on top of each other. They're the same length, but they're separated. So let me draw the projection from that vector, the tip of 4i plus 3j, and I'm going to draw it straight down. And we would assume that we should get a vector that is, or dot product that is 4, see this comes down at 4, times 5 should be 20. And sure enough, if we were to do that, so we know that our length of the red vector is equal to 5, and the length of the B vector is equal to 5. But now we have this cosine of theta, and theta AB we need to figure out. So we can calculate theta AB as the arc cosine of 4, which is the adjacent side of that triangle of 4i plus 3j, divided by its length, and that is going to equal, well, we need a calculator here. And let's make sure we've got this in degree mode. So we're going to have the arc cosine of 4 divided by 5. And that's about 36.87 degrees. So our dot product in this case is going to be equal to, well, I've got 5 times 4 plus 0 times 3 plus 0 times 0 is equal to 20, and that's also equal to 5, the length of our vector, times 5, which is the length of B vector, times the cosine of 36.87 degrees. So, this is the dot product. The one last thing that we need to consider is what happens when one of our vectors are 90 degrees separated. In this case, our dot product has to be equal to 0 because the projection would be at the very tail of the other vector, and also our cosine of 90 is equal to 0. So the thing that you need to remember about the dot product is that it's a scalar, and it tells you how well the vectors are pointing in the same direction. Are they very closely pointing in the same direction, or are they pointing away? Are they pointing opposite directions 90 degrees apart? It gives you a value that tells you just how close those vectors actually are. Now the next video we'll talk about the cross product.